my name is Richard. Welcome to my YouTube channel. Please, are you taking a course in Discrete Mathematics 1? Then you are the right place, because this is an introductory video to a Discrete Mathematics 1. And today, our attention will be based on propositional logic. Before the video will end, we'll learn some tips that will make us understand propositional logic. Then we'll also talk about logical operators. This will be a very interesting engagement, so please be my guest. So we'll look at some tips and terms that will enable us to understand the topic propositional logic. So first, what is proposition? When we say proposition, it's a declarative statement or sentence that is either true or false, but not both. What does that mean? So if we have a statement or a sentence, 6 plus 2 is actually 8. This is true. And 6 minus 1 is equal to 8 is false. So 6 plus 2 equal to 8 is true. It cannot be true and false at the same time. No. And 6 minus 1 is equal to 8 is false. It cannot be false and true at the same time. So any statement that is either true or false, but not both, then is called a proposition. I hope you understand the term proposition. So we say propositional logic is the field of logic that deals with proposition. Or we can say that it's a field of logic that deals with a declarative statement or statement or sentence that is either true or false, but not both. So any field of logic that deals with a declarative statement that or sentence that is either true or false, but not both, then that field of logic is known as propositional logic. The third one is propositional variables. What do we mean by propositional variables? They are common variables that are used to represent propositions. So some common variables we usually use to represent propositions. Those variables are called propositional variables. These variables include P, Q, R, S, and that. So these are common variables we usually use to represent proposition. The next one is true value. What do we mean by a true value of a proposition? A true value of a proposition, or a true value of a is the true value is the true value of the propositional statement. So remember, we said proposition is a declarative statement that is either true or false, but not both. So the value of the propositional statement, is it true? If it is true, then the true value is true. Is it false? If it is false, then the true value is false. I hope you understand the true value of a propositional statement. The next one is negation of a proposition. What do we mean by that? When we say negation of a proposition, this is the opposite of the proposition. So the opposite of something is the negation of the thing. I hope you get that. So listen, let's take note of this, very, very important. We say that if the proposition is true at all cases, then its negation is false. So we say whenever a proposition is true in all respects or in all aspects of life, then its negation is false. The opposite also happens. If it is false, then its negation is true. If it is false, then its negation is true. When it is true, its negation is false. So now let's look at this preposition. The first one, P. Accra is the capital of Ghana. Is it true? Yes, it's true. Accra is actually the capital of Ghana. Then a negation of this preposition, which is usually written as this. This is the sign for the negation. Will be the negation of P will be Accra is not the capital of Ghana. Accra is not the capital of Ghana. So let's look at it. Accra is the capital of Ghana. It's true. It is very true that Accra is the capital of Ghana. Let's look at its negation. Accra is not the capital of Ghana, so its negation is false. That's why we say if a preposition is true in all cases or respect, then its negation is false. And if it is false, its negation is true. Now let's look at the second one. China is in Africa. So remember, let's come to this one. The Accra is the capital of Ghana is true. Then its negation will be false. Now let's look at this one. China is in Africa. Is it true that China is in Africa? No, so it's false. It's not true. Then the negation of the Q will be true. That's China is not in Africa. So China is not in Africa. This is what? This is true. So we say if a preposition is true, then its negation is false. And if it is false, its negation is true. I hope you have gotten all the necessary tips that will make us understand preposition. The next thing we are going to talk about is the truth table for a negative statement, or the truth table for a negation of a statement. So the next thing is that the truth table for negation. Remember, we say a proposition is a declarative statement or sentence that is either true or false, but not both. So we say a preposition can either be true or false, but not both. So, and in our examples that we gave, we say that if we have P, the preposition P, then its negation will be written like this. That's this and P. That's the negation of P, or the opposite of P. So the truth table is that when preposition is true, its negation is false. And when it is false, its negation is true. And we look at it from the very example where we said Accra is the capital of Ghana. So if Accra is the capital of Ghana, then if it is true, then its negation, which is Accra is not a capital of Ghana, is false. Then the second one, if we have a preposition which says that China is in Africa, China is not in Africa, so it's false. So China is in Africa, it's a false statement. So its negation, which is China is not in Africa, is true. I hope you get that. So this is the truth table for negation. The next thing we'll learn is called logical operators. So when we talk of logical operators are connectives. When we say logical operators, they are things that connect one preposition to the other. So we say logical operators are connectives that are used to form a new preposition from two or more existing prepositions. So we take notice of it. When we say logical operators, they are connectives that are used to form a new preposition from two or more existing ones. What are these logical operators? We have four basic logical operators when it comes to prepositional logic. And they are: one, conjunction. And this is the symbol for conjunction. Then the second one, disjunction. Disjunctions. So disjunction, this is the symbol, or this. That means we have two types of a disjunction statement. We'll be looking at it very soon. The third one is conditional statement. Then the fourth one is bioconditional statement. And these are the symbols for each of them. So please take notice of it. We have four types of logical operators: conjunction, disjunction, conditional, and bioconditional. So when the statement is given, you will be able to know whether this statement is conjunction by identifying the logical operator. Oh, this statement is disjunction by identifying the logical operator involved. Or this statement is conditional by identifying the logical operator involved. Then, or this statement is bioconditional, and the logical operator involved will help you identify it. So we take them one after the other. So let's look at our logical operator conjunction. When we say conjunction in propositional logic, what do we mean? So we say conjunction is a logical operator which uses and and, the word and, to connect two or more prepositions to form a new one. So check a preposition. When you see and connecting two things, then we say that prepositional statement is a conjunction statement. So let's look at this. Today, let's look at two prepositions. Today is Friday, and the second one, it is raining. Then we can say P conjunction Q will be today is Friday and it is raining. I hope you get that. So today is Friday is P, the preposition P, and the preposition Q is it is raining. Then this statement becomes conjunction. When you have P conjunction Q, it will be today is Friday and it is raining. So when you see this statement anywhere, today is Friday and it is raining, then you know that this statement is a conjunction, a conjunctional statement. I hope you get that. The next thing we'll look at is the truth table for conjunction. So before we come to the truth table, I want you to know one thing very, very well, very, very important. We say a conjunction statement is true if both sides of the statement is true. Otherwise, it is false. What does that mean? Remember, we said a conjunction statement is any statement that uses the end, to connect two sides of a preposition as one. That statement becomes true if both sides of the statement is true. Otherwise, it is false. That's when the first is false and the second aspect is true, the statement becomes false. Or when the first aspect is true and the second aspect is false, the statement is false. When both is false, it becomes false. It is only true when the two sides of the statement is true. That's why we say a conjunction statement is true if both sides of the statement is true. Otherwise, it is false. So let's say we have a preposition P and another preposition Q. Then P conjunction Q will be written like this. So let's say P is true and Q is also true. Or Q is true and P is true and Q is false. P is false and Q is true. And P is true and Q is also true. And P is false and Q is false. Thus, we have covered all aspects of it. In a situation where the first statement is true, the second statement is false, the first statement is false, the second statement is true, or in a situation where both are true, and in a situation where both are false. Now we say that the conjunction statement becomes true when both statements are true, otherwise it is false. So locate a situation where both statements have the true values. When both have true values, then it is true. Otherwise, all becomes false. I hope you get a truth table for a conjunction statement. So a conjunction statement is only true when both sides of the statement is true. Otherwise, it is false. We'll look at some their conjunction and see if it is true or if it is false. So we'll look at some logical statements that are conjunctional statements and see if it is true or false. Now, for the sake of those who don't know these statements, let's let them know. Actually, Dede Ayew is the captain of the Blasters. Those who don't know about football, Dede Ayew is the captain of the Blasters. And the jersey number he wears is number 10. So Dede Ayew is the captain of the Blaster. That's one aspect of a statement. And he wears number 10. Provided we know this already. And let's say someone made these statements. Let's see which of these statements is true and which is false. Number 1. The DIU is the captain of the Blasters. It is true. And he wears number 8. Is false. As far as the second aspect of the statement is false, it renders the entire statement as false. I hope you understand that. Remember, we say a conjunctional statement is only true when both aspects of the statement are true. Otherwise, it's false. So the day I use the captain of the blaster is true. And he wears number 8. It's not true. It's not true that the day I wears number 8. So it renders the whole statement as false. I hope you get that concept. Let's look at the second one. The day I use the captain of Accra Heart of Oak. And he wears number 10. Is this true? Let's see. The DIU is the captain of Accra House of Folk. It's not true. The DIU is not playing for House of Folk. And he wears number 10. It is true that he wears number 10. But as far as he's not the captain of Accra House of Folk, then the whole statement becomes false. So we say this statement is also false. I hope you get that. Now let's look at the third one. The DIU is the captain of the Blasters and he wears number 10. The first aspect. The DIU is the captain of the Blasters. It's true. He wears number 10. It's true. As far as the two sides of the statement is true, then this statement is entirely true. I hope you get that. Now let's look at the fourth one. The DIU is the captain of Accra House of Oak and he wears number 8. It's not true that the DIU is the captain of Accra Heart of Oak. Even the DIU doesn't pray for Heart of Oak. And he doesn't even wear number 8. Both statements are false. So the entire statement is false. So we say a conjunctional statement is true when both aspects of the statement are true. Otherwise, it is false. I hope you understand a conjunctional statement. So our next logical operator is disjunction. So what statement do we mean by a disjunction statement? So we say a disjunction is a logical operator which uses or to connect two or more prepositions to form a new one. Please take notice of it. Remember, conjunction uses and. Disjunction uses or. So let's look at these two statements. Students who study calculus can take this course. That's students who study calculus can take discrete mathematics 1. Or students who study computer science can take this course. That's discrete mathematics 1. Then the disjunction of this statement will be that's P disjunction Q. Or it can also be P dis. They are both disjunction statements. We'll explain. There are two types of disjunction. We'll explain pretty soon. So this will be students who study calculus, or computer science, can take this course. So this will be the disjunction of these two statements. So if you see a statement like students who study calculus or computer science can take this course, then we say this statement is a disjunction statement. I hope you get that. You get that. Now note, a disjunction statement is false if both aspects of the preposition is false and true otherwise. What do we mean? We mean that when both aspects of the statement in contention are true, are false, then the prepositional logic or the prepositional statement, the disjunction statement, is false. When one is true and one is false, it will be true. So when both are true, it's also true. But it becomes false when both are false. Now, before we come to that, we'll look at the types of disjunction that we have before we talk about the truth table for a disjunction statement. So remember, we said a disjunction statement is false if both aspects of the preposition is false and true otherwise. And I was explaining that this simply means that when one is true and the other one is false, the statement is still true. Then when both are true, the statement is true. They become false when the two aspects of the statement is false. So let's look at an example of that. Kofi is the class prefect or the school prefect at presec. So let's say that Kofi is the class prefect or the school prefect at presec. This becomes true if Kofi is really the class prefect of presec at presec or is a school prefect at presec. It is also true when Kofi is not the class prefect, but he happens to be a school prefect at presec. It's also true. Or it's also true if Kofi is the class prefect at presec, however, he is not the school prefect. This statement is true. It is only false when Kofi is not a class prefect at presec and is also not a school prefect at presec. I hope you get that. There are two types of disjunction statements. There are two types of disjunction statements are inclusive or, and this is the symbol, and exclusive or. The inclusive or statement, so if you see this connecting two statements, then it's an inclusive or. Then if you see this, that's a plus circle by a plus being circled, then it's exclusive or. An inclusive or statement is true when at least one of the preposition is true and false otherwise. What is the meaning? When at least one is true. When one is true and the other one is false, it's still true for inclusive or. When both are true, it's still true for inclusive or. It becomes false when both statements are false for inclusive or. What of exclusive or? The exclusive or is true when only one is true, otherwise it is false. So remember, when only one is true, then it is true. Otherwise, it is false. So when one aspect is true and the other aspect is false, then it becomes true. But when both are true, it's false. When both are false, it's still false. Only one for the inclusive or. So we say inclusive or when only one is true, when only one is true, otherwise it is false. So we look at the truth table for both inclusive or and exclusive or and see how they look like. So remember we said the inclusive or statement becomes true when at least one statement is true. Otherwise, when at least one statement is true, otherwise it is false. So when one statement is true and the other one is false, the statement is still true. When both are true, it's still true. It becomes false when both are false. But in the exclusive or, it becomes true when only one statement is true. Otherwise, it is false. This implies that when one statement is true and the other one is false, is the conjunctional statement, the disjunctional statement is true. But when both are true, it becomes false. And when both are false, it becomes false. I hope you get that. So now let's look at the truth table. So the truth table for inclusive or. So if you see this, then you know that that's a disjunctional statement that is inclusive or. I hope you get that. So when both, remember in inclusive or, it becomes true when at least one is true. It is only false when both are false. So when both are false, it is false. And true otherwise. So when both are false, it's false. When both are true, it will be true. When only one is true, that's P is false and Q is true, it's still true. When P is true and Q is false, it's still true. That's for inclusive OR. So this is the truth table for inclusive OR. Now let's look at the truth table for exclusive OR. So we say exclusive OR statement is true when only and only one statement is true. Otherwise, it is false. Well, so when P is true and Q is false, it's true. When P is false and Q is true, it's true. But as far as they both have the same true values, that's P is true, Q is true, it becomes false. And P is false, Q is false, it becomes false. I hope you understand the aspect of the inclusive OR and exclusive OR. Please, we'll end it here today. In our discussion, we look at the introduction to propositional logic, and we talk about some logical operators. And in the logical operators, we talk about the conjunction, when to know a conjunction is true, and its truth table. And we talk about disjunction. We look at the types of disjunctions, and we know a situation when the situation where each of them, we can identify the truth value of them. We'll end it here today. Please, before you sign out, remember to subscribe to my YouTube channel for more of this and click on the notification bell so that if I post more of these videos on discrete mathematics, you'll be the first to receive it. Until we meet again, my name is Richard.